Dr. Anthony Raj. He has pursued his bachelor's, master's and MPhil in physics. He then went on to pursue his PhD in physics at the University of Madras as well. He then went on to work as a lecturer at Thiruvalluvar Arts and Science College and Idya Engineering College for Women. Since the year 2006, he works as the lecturer and assistant professor at Loyola College, Chennai. With regard to research, he has published several papers in international journals, namely Radio Wave Propagation over Salem, Linear and Non-Linear Optical Properties of Pure and Doped Selenium Malate Single Crystals, and many more. He has also attended several conferences and seminars, namely International Conference on Materials Science and Technology, National Conference on Higher Education at Crossroads held at Loyola College, National Seminar on Crystal Growth 12 held at VIT University, and many more.
Welcome to UGC lecture series BSc Physics Honors Mathematical Physics 2 Semester 2 Lecture 19. In this lecture we are going to see Lagrange's method of undetermined multiplies, application of this Lagrange method of undetermined multiplier to some simple problems in physics. Summary: Lagrange multipliers. We know this Lagrange multiplier is a dummy variable used to multiply some quantity to do mechanical problems. So the method of Lagrange multipliers allows us to minimize functions with the constraints that we only consider points on a certain surface. We know in the calculus of variation there are different kinds of constraints like holonomic constraints, non-holonomic constraints, like that many kinds of constraints are there. Out of those, any one constraint will exist in all the problems. So in nature, physics problems are constrained motion. If those constraints are included in the equations of motion, how those equations of motion can be solved using this Lagrange multiplier? That is what we are going to see in this Lagrange multiplier. So this Lagrange multiplier allows us to minimize functions with the constraints that we only consider points on a certain surface. We know different surfaces are there in analytical geometry like spherical surface, cylindrical surface, curved surface. Out of those surfaces, any one surface, any surface has got is represented by a function. Those functions possesses constraints, so those constraints can be a part in the equations of motion of a system which moves on that surfaces. So Lagrange multiplier allows us to minimize functions with the constraints that we only consider points on a certain surface. To find that critical points on the certain surface of a function f of x, y, z on a level surface, g of x, y, z is equal to c. So here this g of x, y and z is equal to c is a geometrical representation which denotes a level surface, or the function f of x comma y comma z is subjected to the constraint g of x comma y comma z is equal to c. Like that also we can imagine to learn the definition of Lagrange multiplier. So let us find the critical points of a function f of x, y, z subject to the constraint g of x, y, z is equal to c. We must solve the following system of simultaneous equations. The system of simultaneous equations are del f of x, y, z is equal to lambda into del g of x, y, z. Here this del is the gradient. So gradient of the function f of x, y, z is equal to some constant, some variable into the gradient of g of x y z. Here this g of x y z is equal to c. In that equation, remembering that del f and del g are vectors, so we can write this as a collection of 4 equations. These vectors del f and del g can be written as a collection of 4 equations. In that 4 equations, 4 unknowns will exist. Those 4 unknowns are x, y, z and lambda. So the 4 equations are given like this, that is fx of x, y, z is equal to lambda into gx of x, y, z, then fy of x, y, z is equal to lambda into gy of x, y, z, then fz of x, y, z is equal to lambda into gz of x, y, z. So these 3 equations gives the component of f of x, y, z is equal to lambda g of x, y, z in 3 different directions. Gives the component of f is equal to lambda g in 3 different directions. Then the constraint, that is g of x, y, z is equal to c. Like this, the vectors del f and del g can be written in 4 equations. Here the variable lambda is a dummy variable called a Lagrange multiplier. We only really care about the values of x, y in z, not about the variable lambda. So Lagrange multiplier plays a role in finding the values of x, y, z in a vector del f and del g. So this is how Lagrange multiplier is defined. Once you have found all the critical points, you have to plug them into f. You have to plug these critical points into the function f to see where the maxima and minima exist. So the function f of x, y, z will have maximum and minimum. To see the value of maximum and minimum, what you need to do is you need to plug all the values of the critical points into the function f of x, y, z. The critical points where the f is greatest are called maxima, and the critical points where the f is smallest are called minima. So this is the definition of maxima and minima in the Lagrange multiplier. This Lagrange multiplier is used to minimize the function with the constraint. So first we found the value of the x, y, z. That value of x, y, z is obtained after solving the 4 simultaneous equations. Those 4 simultaneous equations are expressed from the vectors del f and del g. So solving the system of equations can be hard. These equations f x of x, y, z is equal to lambda g x of x, y, z, then f y of x, y, z is equal to lambda into g y of x, y, z, f z of x, y, z is equal to lambda into g z of x, y, z, and g of x, y, z is equal to c. Solving these 4 equations can be a hard one. So some tricks can be followed to solve these 4 equations. What are the tricks? Since we do not actually care what the lambda is, so you can first solve for lambda in this equation, because we don't want the value of that lambda. We are in need of the values of x, y, z. So first solve for lambda. Then second, try first solving for one variable in terms of the others. There you got 3 variables x, y, z. So try first solving for one variable, either x or y or z. Remembering that whenever you take a square root, you must consider both the positive and negative values of the square root or negative of the square root. This is the another step we need to remember to solve the 4 equations expressed for the 2 vectors. Remember that whenever you divide an equation by an expression, you must be sure that the expression is not 0. It may help to split the problem into 2 cases. First, solve the equations assuming that a variable is 0. The 2 cases will arise no. In that 2 cases, first solve the equations assuming that a variable is 0, and then solve the equations assuming that the variable is not 0. So, this step, this trick can also be followed to solve the 4 equations. So, this is how the values of x, y, z can be obtained by solving the 4 equations given here. Next, let us do an example to understand that Lagrange multiplier and to understand that maxima and minima. Here in this example, the function given is f of x, y, z is equal to x plus y plus z. This function is defined on the surface x square plus y square plus z square is equal to 3. For this function, use Lagrange multipliers to find all the critical points f on the curve on the surface, all the critical point in the sense both maxima and minima, all the critical points. Then determine the maxima and minima of the function f on the surface by evaluating the value of f at the critical values. So, from this example, we will learn how that critical points can be obtained. Solution to this equation can be obtained like this. The given function is f of x, y, z is equal to x plus y plus 2z. This is the given function. This given function is defined on the curve g of x, y, z is equal to x square plus y square plus z square. So, first we need to find del of del f. So, del f is equal to 1 comma 1 comma 2. So, this is del f, and del g is equal to 2x comma 2y comma 2z. So, these are the values of this del f and del g. Then the equation to be solved will become equations to be solved will become 1 is equal to 2 lambda x, that is f of x, then f of y again 1 is equal to 2 lambda y, then f is at 2 is equal to 2 lambda z, 2 lambda z. So, to solve this, note that lambda cannot be equal to 0 if because if you take lambda is equal to 0, then this whole part whole right hand side of the equation will be 0. So, lambda cannot be equal to 0 here. Then we get x is equal to 1 by 2 lambda. Earlier you got 1 is equal to 2 lambda x. So, x is equal to 1 by 2 lambda, like that 1 is equal to 2 lambda y. So, y is equal to 1 by 2 lambda. The value of y also will be y is equal to 1 by 2 lambda, and z is equal to 1 by lambda. These are the values we obtain in terms of the Lagrange multiplier. Now, plugging these values into the surface. The surface or constraint given here is g of x, y, z is equal to x square plus y square plus z square. This is the surface or constraint given. So, plug these values here. So, we got 1 by 4 lambda square plus 1 by 4 lambda square plus 1 by lambda square is equal to 3. So, solving this we will get lambda square is equal to 1 by 2. So, lambda is equal to plus or minus 1 by root 2. So, this is the value of the Lagrange multiplier. Putting these value of lambda into the above equations, the critical points are obtained as. Putting these value of lambda in the above equation, the critical points are obtained as root 2 by 2 comma root 2 by 2 comma root 2. This is one set of critical point, and the other set of critical point is minus root 2 by 2 comma minus root 2 by 2 comma minus root 2. Here, to get these two critical points, the value of lambda, that is plus 1 by root 2 and minus 1 by root 2, both are taken into account. So, we got the critical points. Now, this is the solution for the A part in the given question. In the given question, it is asked that use Lagrange multiplier to find all the critical points f on the given surface. We found all the critical points f on the given surface as root 2 by 2 comma root 2 by 2 comma root 2 and minus root 2 by 2 comma minus root 2 by 2 minus root 2. The next thing what we need to do is we need to determine the maxima and minima of the function f on the surface by evaluating f at the given critical points. So, the maxima and minima can be obtained as, we know the maxima is a point where the value of the critical point is largest, and minima, maxima, minima. Maxima and minima can be obtained as f of x comma y comma z is equal to x plus y plus 2z. So, we have f of root 2 by 2 comma root 2 by 2 comma root 2 is equal to 3 root 2, and that f of minus root 2 by f of minus root 2 by 2 comma minus root 2 by 2 comma minus root 2 is equal to minus 3 root 2. So, we got the two values as 3 root 2 and minus 3 root 2. Thus, this root 2 by 2 comma root 2 by 2 comma root 2 is the maximum, and the minus root 2 by 2 minus root 2 by 2 comma minus root 2 by 2 comma minus root 2 is the minimum. So, from this problem we learnt how to get the critical points and the maxima and minima for a given function defined on the surface using Lagrange multiplier. Here we first solved the 4 given equation and we found the value of the Lagrange multiplier lambda, then we plugged that value into the given equation and we got the critical points. Then we got the maxima and minima. So, where the value of the critical point is largest is the maxima, then the value of the critical point is smallest is the minima. This is a thing we learnt from this problem. Next, let us go to another example. The function f of x y is equal to x y on the curve 3x square plus y square is equal to 6. Here the two functions x and y are in multiplication mode. In the earlier problem we saw the x and y are in summation and square. Here that x and y is in multiplication form. So, how we can get the critical points and the maxima and minima using Lagrange multiplier? Let us see that here. So, solution to this problem is obtained by taking the given function f of x comma y is equal to x y, and the constraint given here is g of x comma y comma z is equal to 3x square plus y square is equal to 6 is the constraint given here. So, first find the value of del f. The value of del f is equal to y comma x, and the value of del g is equal to 6x comma 2y, 6x comma 2y. Then the equations, 4 equations which is del value of del x, 4 equations will be y is equal to 6 lambda x, then x is equal to 2 lambda y, and 3x square plus y square is equal to 6. So, here only 3 equations. The reason for that is there is no z component. In the given function there is no z component. So, only 2 equations, then the constraint. So, only 3 equations we got. Now, plugging the first equation into the second gives, let us keep these 3 equations as 1, 2 and 3. Plugging the first equation into the second gives y is equal to 6 lambda into 2 lambda y, which is equal to 12 lambda square y. So, this is the value of y. Here if y were 0, then x should be 0. If y is equal to 0, x also will be equal to 0, which implies that this 3x square plus y square is equal to 6 is impossible. Y is equal to 0, x is also equal to 0. So, 0 cannot be equal to 6. So, this equation is impossible. We can divide y. So, to get the value of x, we can divide y as 12 lambda square is equal to 1. Now, plug the first equation into this seventh equation. Seventh equation is this one, 3x square plus y square is equal to 6. Now, to get 6 is equal to 3x square plus 6 lambda x the whole square, 6 lambda x the whole square, which is equal to 3x square plus 36 lambda square x square, 36 lambda square x square. So, this can be in a simplified form 3x square plus 3 into 12 lambda square into x square. So, 36 is splitted as 3 into 12. So, 12 lambda square exists. Instead of this 12 lambda square, we can plug in 1. So, this equation will reduce to, which is equal to 3x square plus 3x square. So, x is equal to plus or minus 1 and the value of y is equal to plus or minus root 3. So, the 4 critical points are given by 4 critical points are 1 comma root 3 comma 1 comma minus root 3, 1 comma minus root 3. These are the 2 critical points. Then the next 2 are minus 1 comma root 3 and the minus 1 comma minus root 3. These 4 are the 4 critical points. Next, we need to find the maxima and minima. So, the maxima and minima, f of x comma y is equal to x y. So, for the first critical point, f of 1 comma root 3 is equal to root 3. Then f of minus 1 comma minus root 3 is also equal to root 3. Then f of 1 comma minus root 3 is equal to minus root 3. Then f of minus 1 comma root 3 is also equal to minus root 3. Thus, this 1 comma root 3 and this minus 1 comma minus root 3 are the maxima for this given curve. Then this 1 comma minus root 3 and minus 1 comma root 3 are the minima. So, from this example we learnt how to get the maxima and minima for a given curve defined on a given surface, for a given function defined on a given surface. This is first we need to find the Lagrange multiplier and solve using that Lagrange multiplier, solve the given equation, then plug in the given equation into the constraint, then we will get the critical points, and using the critical points we can find the maxima and minima in this function. In this lecture we learnt the Lagrange multiplier. This Lagrange multiplier is allowed us to maximize or minimize a function with the constraints. That Lagrange multiplier is denoted by a dummy variable lambda. Then the critical points are the points obtained using the Lagrange multiplier. Then the critical points where f is greatest and are maxima, and the critical points where f is smallest are minima. This Lagrange multiplier is for plane pendulum. So, this Lagrange multiplier can be applied for plane pendulum, simple pendulum, like that. In many physics problems, this Lagrange multiplier can be substituted and we can get the values of variables in that physics problem. These are all the concepts we learned from this lecture. After listening to this lecture, we can answer the following questions. Define Lagrange multiplier, what are critical points, then give the steps involved in solving the equations of Lagrange multiplier. These questions can be answered after listening to this lecture. Thank you.
Right.